kind of improvised. So finally got some time to do this. I guess not everyone is clocking in here. It's anyone who's been watching this on YouTube is probably going to see this or something, later on. Okay, so now let's switch a bit so you can. I think it's always better. It's like nicer to watch it with some dark theme. Although I used a light theme always because of it helps with my astigmatism. Anyway, I actually did some work that you haven't seen. So I'm just going to jump into everything, right? And if you have questions, just write something on the chat. So I'm just going to type this up. So if you have any questions, write it here in the chat. Okay, so right. Let's see where I left off. Okay, so there are a bunch of things that aren't done. So okay, so here we go. Yeah. So what I need to do is when I start with this. Hang on. What's this? So it's going to register declarations, right? But we also, it's in the global context, in the local symbols, in the symbol table, all of that. Okay, so I'm not sure how I want to do this, so bear with me. I'm just going to, improvise a bit. So if we have in methods register, the code looks like this. So we are going through these methods, and we have one process generic, which is run one. Okay, so when it's like that, the generic things. This is going to be completely removed, so it doesn't, conditional, generic, it doesn't make any sense. So what does that do? Okay, so we have generic methods to register for the type, right? It doesn't make much sense. But okay, so when do we populate this one? I think we do populate that one someplace. Right, so here we go. Oh, it's during the okay, so if you have type parent and the type parent is a generic type, I don't remember anymore. So we are going to do stuff, but we're not doing it now. So things are going to break. Okay, so blah blah. So this is a to do on these, and a method includes. We're skipping that as well because all it includes will be resolved already because we're not doing any anything weird here, and we're gonna skip these as well, all the methods, and I think eventually this will be okay, so no, it's going to be much simpler. So we're going to remove all those bunch of stages. So okay, anyway, well, let's this pause here. So we're going to go through the declaration analysis here, and you see we're going through them in this order, and since they are now, we are going. Okay, so what we do is that we analyze these declarations like this, right? Because we already registered them, and then we can do them in order, in this particular order. uh, now that was for the normal pass, but when we're doing the other pass, we don't want to do it like this. So if we're going to do the analysis declarations, so we're going to say if okay, so if stage is greater than analysis decals or equals to that one, we're going to do the whole thing here. So okay, if it's not, hang on, we can just jump. So if less than, then go to exit. We haven't defined exit, but let's do it like that. Okay. So I guess, I mean, this is the nice thing about GoTo. You can wrap this now. Do while. Then we'll get some break. Okay. But okay. Anyway. So instead of going to for each for every unit, we are going to go through these registered things that we have, the copied cont ones. And so if I remember correctly, what it's going to do is they're going to put them in here, and what the heck do we do with the conditional? So in the case it's a conditional, we do it like that. If it's not, then let's we can also else we can kind of disable it, so we can say like the decal is I mean, we can delete it, right? So decal kind equals decal, poisoned or something, erased, right? We have erased. Okay. So now we're going through the for first of the we're gonna like put everything in a single heap here. So we are after this. I guess we can just go, add these copied cons into vec add and copied into copied cond if decal kind is not a decal erased. Okay, so we want to do one more thing. So if what's it called? We should be doing other things here, but okay, let's just go like assume everything works, which it doesn't know. Okay, so if it's not erased, then we add it, this particular declaration. So now we have all our real ones, I guess, in here, because this one will resolve everything. Okay, so we are adding, like, add all the normal globals, top level declarations, and then the second one would be, add all the conditional declarations. And the reason why we did that in two steps like this is then the first and the conditionals can depend on the declarations, the top level declarations that are not conditional. And I guess that's the only thing I really want, Anyway, okay. So let's continue here. Okay. And so we just add this, and we have like this big list of copied, right? So now we can, because of this, we can now just do for each, and then we go through all the declarations that are in this copied, right? So that would be all the declarations. And see, we create the context per unit, right? So This is a bit not really optimized. Let's see what it does. Right, so it requires a locals list. Okay, yeah, it will be fairly optimized. Okay, so you're gonna put this one as, oh, it can be inside. And the declaration would have a unit. So hi, by the way. So it's gonna have a unit. So we can grab that one. Call it unit. Another one is as a scope. So that it's zeroed out, right? And well, we can just, I mean, it just needs to be empty, right? So I can just, yeah, I just said something, right? Okay. So the active scope is empty, and now we can just start doing all of this. So it usually would be like doing things in order, right? So it first analyzes all the attributes and all the enums and so on. Now, the problem with this is that now we're inside of this parameterized one. It's just going to be very gnarly to kind of find out which ones are done in what order and so on. So we're not going to do this at all. So we're just going to go and, SEMA analyze decals. Here's the decals, right? So it just goes through. So we're just going to analyze that particular declaration, right? And we need context, yes, and the declaration. And then we just destroy that particular, so generic defines whatever. So okay, what's this? Check type variable array. Okay, so while we're doing this, there's hang on, there is something. What you gonna, there's this. Okay, so we still need to do this, I think, and then we kill everything, right? So we're doing this again, this decal unit. So what happens if we do this, right? If it's okay, then we're false, blah blah blah. So what is that? What is the info? It's going to be like the unit check table. How did I do this one? Okay. So how are those added? Okay, so yeah, we can probably, like, we're yeah, we can probably do something like, okay, let's say we do it like that. Analyze inner function pointer. So we're going to oh, anyway, we're just put it to do there. Okay, so we kind of, oh, here we go. So the compiler context error is found. Which one is that one? Okay, so the global context. So F, like if we have if global context errors found, here we go. If it's found, then we have an error and we just need to return Poisson decal, right? Something failed, we just return a Poisson declaration. something failed, we return a post declaration. Okay. And then we're supposed to do the analysis with CT echo, assert, and then we do the functions, right? And then the interface, and then finalize. Okay. So, okay, that means we have to defer those. So, okay, so the analysis function is just doing these on the units. It's a bit gnarly because we have these methods and then we can't use them. I don't know if I use them again. I mean, if we don't use them, I could just clear them. Oh, okay, they're used. Yeah, okay, they're used. But what I could do is kind of see how long they are, right? And then I can do the whole thing, going through these units belonging to these modules, and just perform the same thing, I guess. So instead of doing this, okay, this is, I guess, okay. Instead of doing this, I could, before this happens, right, we are going to keep a list of the state of everything before it happens, so we can kind of no, we can't do that. The reason why I don't want to do it is if we do it like this and then we during unit register optional global decl we are going to have resolve things, and that resolving things might create new types into this module that we are modifying, and that's just going to be horrible. Okay, so we're going to go with what we had. So, and that means that we are going to skip some parts of this analysis. So I think it's going to be okay, right? If we have in this particular thing with functions, so if we're already analyzing functions, then we want to analyze these functions. That's basically what it does. And see, you have these passes here, and then you do these function bodies and so on. So it's essentially that. We are going to have a lot of things to check for as well, but for now, this is okay. So if stage is less than stage, what is called analysis, what's that, functions. If it's less than that, we'll go to exit. Then we'll go to exit. Okay. Then we are going through all these. Okay, we are not, let's see, we're not going for the function bodies, right? Okay, so again, we are, I guess, doing something similar. So we are going to do the same thing with for each and going through declarations, right? So again, this, and in this case, we don't need to, like, if it's a function, like we already only want the decl expression kind, decl switch, decl kind. So only if case decl and it's a function, or a case decl it's a method. Do we have, if it's, this is different. No, I just keep them as the same thing, right? Yeah. So if it is, then we are going to do this whole context, blah, blah, blah. So I can put this context actually outside here. Then I don't need this thing here. So we are going to so its unit is going to be the one in decl. So it's actually like in some ways it's more complicated, and in some ways it's actually easier. So see, we have this analyze function body. We have to move that one outside, otherwise we can't do it. So it's in the Sema internal, most likely, right? So we are adding it here somewhere. So unfortunately we have a bunch of things that we will need to clean up later. Okay, so now we have the analyze function body, and we need the method, right? So that's our declaration. And then we are destroying that particular context, and we might be done, right? We might be that if there's an error, then we are done. Right? And the default case is just we're going to break here. We're not doing anything, right? So now we handled all the functions, right? So we are done with all this. So now the next thing is analyze the so if analysis, and then we have like this interface. I don't know what the interface does, so we'll have to look it up. I think it's like checking that types are implementing the interfaces. I think it might be that. So that's why you do it, like after everything is analyzed, you want to make sure that okay, it does actually, satisfy the interfaces. It could be done together with the functions, to be fair. So let's see analysis interface. I'm just going to see how that one is implemented. So you see here, okay, if it's an interface, right, then we're going to check interfaces. So it's just going to do that, and it's creating a context that it can do like similar, right? So anyway, check interfaces. I want to have this one. Again, I need this one in the external interface, and maybe we'll move everything later. So it's going to be nicer, and then we don't need to have these here. But let's move it for now. So if a stage is less, then we go to, could you ever need to do this in this stage? Like, I don't see it happening, to be honest. I don't see it happening, because let me just check this, but I think that maybe it's like overkill to do this in this particular thing. In this particular case. So I think the module could never, like checking this interface should never ever check interface. Let's see here. Okay, so it's resolve if I stack things. We check for the interface and we resolve symbol, but we're not doing any semantic analysis. So that means that this could never happen, I think. So finalize, I think, doesn't do anything, right? So it's, let's see what finalize does. So finalize doesn't do anything, right? Okay, so then we're done. So we can say basically set assert that stage is less than analysis interface. That means we don't need to do it either. Okay, and then we're done here. So we are like we should have also should be working here by this point. Let's see here. Because we're checking after every well, we just have it at exit, so we can do like this exit, and then we do the check, right? So then we don't need to do this check here. No, we do it, so we can do it early. Sorry. Or maybe we want to check everything. Sorry. Oh, we are going to check everything, and we're breaking there. So now we're just doing this after every part instead. So here we don't continue if we found it, but if we go to exit, we don't need to handle it correctly. Okay, so then we're not doing the method register. So let's see how it breaks, right? So now I added some functionality. Let's see where it breaks. So the lookup is going to break, of course. I have a lookup that it's not working. But I just want to see if it, you know, anything happens here. So, so you go. So, so the instance here. Okay, well, let's see here. So we have a generic declaration. So let's see. We have a parameterized declaration. We have the generic here. The generic declaration. Oh, this name. So if the we don't have an instance here, do we? Yeah. Okay. So here we go. Okay, so it's breaking earlier. So is okay. Whoa, it's defined in generic module. Did you forget the parameters? It's found. Whoa. Progress. It's insane. I just have to say, like, it's insane how annoying it is to do this. It's been like it's so different from what used to what the original, like, the generic modules are. So you kind of both need to kill off the generic stuff and then add this, which is not working in a way that anything else does. Okay. Okay, so the element creatable is defined in a generic module. So let's see what happens here. Now we're going in here and we're going to find this particular thing, right? We are like, do we get to this point or something? We're gonna get, like, do we have an instance? So let's. I think this is what happens here. So we're gonna go in here and see what the name is here. So the name is okay. List, that works apparently, and hash map still works. But we have this thing, other thing that's going to be okay. Oh wait, it broke early. Okay. I thought that is defined in the generic. Let's see where that kind of flows. So where do we get that? So it's we're gonna track, like, how it ended up in this way. Okay, so boom, we are hitting this and we're solving the generic type, right? Okay, so we are in the, let's see. Okay, so we're solving the type, we're solving the generic. We have, like, going into the parameterized identifier, right? Okay, we are hitting this instance. Okay, let's we shouldn't have. Okay, we're fine. All right, so here we go. Like, we are hitting here. Okay, wait, I did, perhaps that was wrong. Okay, so we're here, right, with the list. Okay, so and then we end up here. It's not there. It's resolving symbol. Okay, so it's resolving symbol. It gets to, common here, and it's doing this while it's this. Let's see. It's analyzing the parameter. Oh wait. Oh wait. So whenever I do something like this, right? Whenever you register a global declaration or something, look at this. It's supposed to be like setting the is it templated? It's set templated here, right? So we're going here, right? And we're going in here, and we are looking at this declaration, which is an index of. Is that the first one? Okay, so we have an index of a string. That is odd. So we have a list, right? So the declaration here is what? Index of string. Okay, wait. This is when we're resolving it and we're creating that particular. This is like it's broken somewhere here. So when we're creating our new instance, let's see what happens. So I'm sorry this is like going so slowly, but there is just it's just bad. Um, okay, so here we go, and we are getting the parameters. So basically, here we are baking the declarations. We are looking at this alias here. We have this alias, and it's in a unit. So now we're actually using that unit, and it already exists. So hopefully, yeah. Anyway, so it's in this module list, right? So we are having some. We're going to create a suffix here. So after this has this suffix. So the instance itself. I hope you can see everything here. So the instance, let's see what we've got that one. If I just close this. Okay, so the instance now has this name, which is just dollar string dollar, which is the end of it at the end of the okay, and that's the suffix actually, but that's the name of it, of this generic declaration. Okay, so we're going to pull out the instances that we created here. So there's the instance declaration, and so we see the name suffix is now this is the like the nice one, right? And we have some parameters, and we see the type there. And we have a htable, and it's not going to work because it's empty. Oh, maybe that's what breaks, right? That should make it. Okay, so we are going now, like, because the module might have multiple generics and they are assigned an ID. But so we want to add all these generics that we had in this module that matches the ID, because we might have sections. So basically this G here is in a section. We might rename that one section straight off. Maybe I can just stop there and just have generic sections. It's just going to be a much better name. So we're going to stop here. I called it generic section, but then I refactored everything, and then everything got kind of messed up. Okay, so get in here, and we are creating this instance, and we are creating those declarations. We have the suffix and so on, and we get to this point where we start. We found this declaration, the instance, this template that we are going to use, right? And this template has a bunch of declarations. So we are pulling those out in this case, and we now get the list where you can see that there's a list here of the first declaration is like element, predicate, and so on. And we are adding those to a list. Basically, we're not doing anything more than that. So after this, we're done, and we can just continue here. And now look at this. We are creating we have a symbol list for this so that we can do a fast lookup, or that's the idea anyway. But turns out it doesn't work. so this one is actually used, and that's why we get problems. So I'm going to remove this one. I'm just going to be in favor of actually using the main table, which will work. So we are going to the main table. That means like the module is going to get these declarations with suffixes. So we are going to use that instead. Okay, and let's see here. So we fail now because we are looking up, like looking for the symbol here, and it's not going to work. So what we're going to do is that we know the instance. So we're going to, create some Scratch here, and then we're going to be like Scratch buffer. We're going to append the instance name here, the symbol itself. So hang on, will this work? It should work, right? Okay, so we are going to add this. What was the name of it, right? And then we're going to add the suffix. So Scratch buffer append, and then we're going to do like the instance has a suffix, instance decal, and then a suffix, name suffix. And this is going to be like we're going to const. Sure, this symbol should exist. Symbol, and we're going to do Scratch buffer turned. So we are looking at this, making this an unturned symbol, but that's going to work anyway because we are because now this symbol is probably generated somewhere. We already did that here actually. So now we can do a lookup like this normal find the symbol module find symbol, which is a standard thing we do, and then we get the module, which is the module that we were using, and then we have this new symbol, which is the symbol there. So we can do it like this even, right? And then we either get the symbol or we don't get it. So let's say decal symbol. I think it's going to be like it's going to scratch. Yeah, it's going to remove this anyway. So we are okay. So we don't need to do this part. So instead we just do it like this, right? So let's see if this works better. I mean, it will still not work for some things, but that's different. Okay, we are looking at this. We are getting. Hang on. Did we already get the candidate? If we already have. Okay, so we have here we have a candidate, and we try to look it up in this particular generic. So we have to do a similar thing here. So we can be like const char full qualified name, and then we're going to do like so we're going to Scratch buffer clear, and then we're going to Scratch buffer append the name. Where is that? So then the symbol. Do I like refer to it? Okay, found name. No, yeah. So that's the name, right? And then we're going to add Scratch buffer append, and then we're going to get this generic instance that we had. So generic instance, and we're going to have the suffix instance decal, and then we're going to have the name suffix from there. And now we can look it up. So if what module was it? Okay, that's the phone module, right? So decal candidate is module find symbol, and then we take this module, which is the module that this was found in, unit module, and then we do a oh, hang on, this will not look up the local ones. This will not be a local lookup. Okay. So you found it in there, and then you need to look up the I mean, you want to do everything, right? Module find symbol. I don't have anything better here. Like these are all the. Okay, no, those are all the symbols. Okay, those should be. So module. And then we have this Scratch buffer interned, right? And if we find it, we found it. gonna be like 1,000 bucks from this. Yeah. Sound okay, by the way? Is sound okay? Let me know if it isn't right. Oh, it broke. Okay. Okay, it broke for something completely different. Whoa. Okay. Um, oh, wait. Okay. So, actually, I did something wrong here. When I created a parameter here, back. Hmm, resolve parameterized. Okay, there's at some point here we go. I am creating a type expert, and what I should be doing then is that if it's not a type ID, so if it's a const type ID, then we should set the type to okay. So this is one place where we kind of handle and fix up evaluate the parameters. So look here, if we get to type info, we go into this part, and then we resolve everything and blah blah. But what happens if we have a const ID here? Then I start to do funky things. But let's do it like this. If I fail, like if I find it here, we can set this type outside. Type it type. Okay. So then we can retry in here. Retry. Resolve type maybe. And let's see here. Okay, so if we have a type ID, then we go into like type. Okay, we get the type, which is a type equals param const expert type ID. Okay, and then we are changing this into no, it's fine as it is, right? Then go to what do I call it? Resolve type. Okay. That means that as I do this, okay, here's another type. Okay, just I guess type. Okay, resolve type. If we go in here, like we have the type here, and then we want to rewrite this. So expert rewrite as a const type ID, and then we're going to get like the expression, which is the param, and we're going to get the type, which is the type info type. So now we rotate, and now we're kind of fine here. This should be okay. So now we instead always get a type ID, which is okay. That's what we are expecting anyway. Okay, let's see what breaks. Boom. Okay, we are what's not defined. So let's see what wasn't defined. Okay, is there something else? Okay, so this is not a type. Okay, that's too bad. This is not a type. So, okay, we have the type identifier, and it's not a type. Yes, it's not a type. Like, the thing it's expecting here is kind of a type def instead. And it was kind of stupid to make a decal, I guess, of that. So, but I guess I'll just bite the bullet here. So we resolve it into a function, into a symbol, and then we can find that it is a variable, right? And so if it is a compile time type, it's going to be okay. But apparently this is not a type. Okay, let's see what we have here. Right, so the declaration is type, and it's a var, and if it is a var, it should be a CT type or a CT local type. Oh, maybe I didn't change that. So let's go back. So where we go? Here we are. So also when we do this, we should be creating. Okay, what's this? So let's stop here. Why does this create an error here, or underline or something? It's okay. Okay, because the type info might not be. Oh, you're right, of course. So expected non-optional. It's we can just jump to this part here. So now it's going to be fine because we're not accessing the type info. Okay, but once we do this, what am I working? I'm working on the updated modules. That's what's happening. Okay, so where are the declarations? So okay, so if the expression, okay, so the expression is always going to be like a expr const. So let's see, param, and then param expr kind is going to be like expr const. This is always going to be true. So, but if it is like a expr is const type ID, in that case we are assuming it's a CT type. So we're done. Okay. So master 3 chord. Do you was that a good enough explanation? Okay, let's see. Okay, we had some. Oh, now we got like type could not be found. Did you spell it right? Okay, let's see why that happens. So now we're inside of a definition. So we're in here, right? Okay. So there was someone there who wanted a ban. Okay. So let's see here. We are doing what? We are here. Type could not be found. Okay. Oh. Okay, could not be found. Let me spell it right. Right. That happens in more than one case actually. It's actually here, right? So the name resolution again. It's not caught, and which is, I guess, fine. What I do is kind of patch that in early in this, so we have this. Let's see, some report error and deck. So we are here that we can't get it. So let's see what the context is. So I would expect the context to be one that has this generic set, but it doesn't. So we are going into this parameterized identifier. Uh, we are resolving generic types. Let's see. We start here in the okay. We are resolving some declaration. We are resolving a parameterized identifier, and let's see here. So we are in here, right? And we go in here, and so we are analyzing this symbol, which is, what symbol is that? All right, so we're going to in here into, you know, analyzing this, but now this declaration is this list. It should have is a list 0. That looks wrong. Okay. Yes. So it has some idea. Okay. First of all, before I fix anything like that, I'm just going to fix this because this could be something that is due to. Okay. So the expression kind. So expert expert is const type ID. Oops. Damn it. I don't know what the heck. What the heck? Okay, so the type is a type const expert type ID. So then we have a type. I guess it's not. It's fine. It can't be recursive now because it's already resolved. Okay. It's master record. Okay. Alright. Master RC. Okay. Generic modules are, yeah, it's kind of like templates in C++. But it was based on macro on modules. So now we're kind of decoupling it, but it's not. It's still kind of a concept, more of not C++ concept, but it's more of a grouping. But now the grouping is arbitrary. Okay, so we go in here. I'm going to add these, and so the expression now, it's always going to be like a type ID, right? So in the case of it's being a type ID, we already have it's already okay. Like, we can't get this wrong. So that means we just need to resolve the underlying type. And we don't see this happening because now it's already handled. And so we need a type here. And then we are, okay, so then expert is const type ID of this particular param. If it is, then we can do const expert type ID, and then we're done. Yeah. So now it should be mangled, at least mangled in the right way, rather than being mangled as a 0 or something. Okay. Okay, we still haven't, like, if I go one step further here, we can go like type could not be found, it is spelled right. It's the same error, but we are now getting something better. So the declaration is this. Oh, let's start with a parameterized identifier. So our symbol now that we are analyzing is this particular symbol is a list string. And this one has a should have a generic ID or something. So the declaration itself is templated. That means that there is a here a generic instance that it belongs to. And because it does, that happens, then this context should be updated with that particular instance, and it isn't. So we are doing, I don't know why, because I think I added that. Let's see here. So it should do that for every context. Anyway, so let's see here. So if we have this generic instance, where do we set that? Okay, so when we do here, we do set it, but do we set it elsewhere? So apparently we don't. So then we need to do that. So every time we analyze a declaration, we create this temporary context that we're going to use, and we're going to set this context to the generic instance is going to be like decal if the decal blah 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 is templated. In that case, we're going to take like the decal. Here's we store that a bit compact. So we have module instance. No, is it instance decal? No. Instance, generic instance. Okay. Otherwise, it's going to be no. So we have like a generic instance, so it knows that it can use that. I'm not sure here whether we need to do this more. So maybe there are other places where this is needed. We also have the contracts, but we'll get to that eventually. So we have like so many tests that should be able to kind of work ourselves through those tests once it's working. Okay, so look, we actually got somewhere. Look, it's not the same error as before. Okay, globals from other modules must be prefixed with the module name. Okay, let's see why that happens. So again, we are going in here, like looking for with must be probably like prefixed with global from other modules. Let's see here where that happens, or why that happens. So I'm just right now I'm just throwing shit at it. To be honest, it's not the way I would prefer to do this, implement this, but it's a bit tricky. So we are analyzing the this particular declaration. So it's this hash bytes, and hash bytes. What is the unit used for that? So the current unit, by the way, is here. So we are in this module which is called HMAC, right? So std hash HMAC, and we have this hash thing which is inside of something else. So we have, let's see here, declaration unit. So decal, where is the decal? Right. It does make me a little surprised that this happens. So decal, and this it's defined in MD5. But okay, so let's look at that. So we have the hash. There are different ones, and maybe I get a match that doesn't, shouldn't be there or something. Um, so let's look at that again. So we are getting the errors here. We have the hash bytes. So let's look up the hash bytes in the library. Okay. We can get there are a lot of places where you have the hash bytes. So hash bytes are defined in MD5 correctly. And hash bytes are also defined in as a yeah baby. So they are also defined as something in HMAC. So they are different things. So hang on, I need to fill up on some of my tea, and I will be back in about 5 minutes. In 5, I'm just going to write that in chat as well. So I'm going to try not to make this too long. Just because it's it's late here. So okay, see you around. Right. Thank you everyone for your patience. Took a little longer. Okay, so actually, I understand what the problem is here. What you have here are these, and they should be patched in and looked up, but they are not. So I think I'm going to go back and kind of create a small sample. I'm going to turn off the standard library so you can see if this actually happens. And so here's the code. This from something else, and somehow all the highlighting got messed up. So we have the generic. We are going to have something in here, which is going to be like I don't know, an int foo, and it's going to be initialized to a constant, to whatever constant that is. Okay, so in the const in there, and so in our test module, we're going to import the generic, and then we're going to have a simple main, which is going to do x is equal to this. Value, of course. So like this, and we're going to have the generic. So the generic. Yeah, I think actually, like, I won't do too much. So master record. Okay, so master record. I won't do too much because I need to sleep on this after, I've coded for maybe an hour, and then you should really be thinking about what I've done so far. So this one I'll like fix some bugs here that I didn't remember, but then I'll try to think about maybe there are weaknesses in this that I should be handling. Okay, so I assume that this will not work now. So okay, so let's see, the globals from other modules must be okay. This is even crazier. Maybe let's see what happens. What happens if I have like this, right? It should still like does this work? Does this compile? That was really interesting. So okay, missing return statement. Yeah. If this actually works when we are I have something that actually works. That's nice. With a bit of generics. Okay. So okay, that worked. So now we need to do it with the const, right? So the const, and let me see like why this doesn't work. I think it's okay. I think I know why, because they're creating this declaration, and its declaration itself is patched in, basically. And when it's patched in, it's okay. It looks like, look at this. Must be. So let's again look at where that happens. I'm just going to backtrace from this and see where this happens. We are creating those declarations on what they look like. The declarations, these constants holding these things. So here we go. Like we have the verdict, and we do analyze this identifier, and then this identifier is a declaration, which is the const, right? And let's see, where is what's the unit that it belongs to now? Because it should belong to, okay, so it belongs to the test, right? And that's wrong. And that's why we get this problem in the first place, because when we do this, create these declarations, let's see where we do it here, right? We do set it to the unit that invoked them, but that's wrong. They need to be set to the unit of wherever those like maybe the first generic, I guess, like this generic, yeah, generic. So there are several places where this is defined. Generic unit. So we're gonna just grab the first generic, the one that we found the first time. It's not really that important now because units, they only like the matter with local visibility. Okay, but then let's see what happens. So I think this will. Okay, now it didn't work. So what do we have? So analyze this. Okay. Oh, it should be resolved. So when we are doing this thing here, let's see here, we are creating those declarations here. Um, on where does this fail? Does this fail? In here, perhaps decal, because we are like analyzing these declarations here. I think that's where it fails actually, because I'm setting it differently, and then I'm just gonna be here and just reset it. I think, like I can just, you can just set that later on to this generic unit. That's gonna be fine. Just override that. Oh, it fails still. Okay. Then I need to have this. So if decal unit not, then blah blah. Okay. So let's see where the actual problem is. So we are in here, right? And okay, and it expects us to have set the unit, but somehow I'm not supposed to. I don't know. Why doesn't it work when I do it like this then? Is it because C is a different unit or something? Okay, so now we are looking at the const, okay? And now it doesn't have a unit because of why? Look at 0, but didn't I just... Okay, so maybe the generic doesn't have a unit. That might be true. Ah, look at that. It doesn't have a unit. Why doesn't it have a unit though? Like, you get through all these... We have this alias. Okay, the alias module... the alias. This is going to be right. So we're going to go for the one to found, and now it's going to work, I think. So actually I didn't really need to do the analysis there because it's going to be like mostly working anyway. But I just want to drag it through the normal analysis. Ooh, that's interesting. Okay, where does that happen then? Okay, I'm just going to put two of these. I'm guessing that it happens in there. So we go there, and then we continue, and it works, and then we go there again, and then it fails. I think there's like these param. Okay, here we go. So let's see why we fail. We're going here because we are okay. We are analyzing the what's this though? We are okay. I think it's what's this? R value. Okay, so let's not go through this analysis because it's kind of broken as hell if I do it. So instead we're going to say it's resolved. So done, and we're going to set the type is it's going to be the same as its param type, and we're done. And now we should really remove that printout as well. So this one. This should really be a search span. Just in case something happens. Right. Oh, we had that one anyway. Why though? Okay, so we are in here. We go to, you know, we when it costs this R value and the decal is that. And like the decal here is the const and it has a what kind of type? Oh, just set the var type? Maybe I didn't do that. It's a param CT. I mean, it should be a var decal const, I guess. But this is a bit weird. So we're going to do a cost R value. If we do a cost R value on an identifier, oh, it's going to be, it should be a CT identifier, right? But we don't see that because it's set something else. Okay, let's go back. So we shouldn't set that one as a parameter. It should be a var decal const, right? I guess this should be a type def actually, but now it works. Hooray! Let's see if I can get the types to work as well. So I'm going to set a type here, and we're going to set the int. It's going to be the type, right? So then we have this very simple, very simple generic thing. And it works. And we can return this x, right? So we should get 4 returned. Okay, cancel. 4 returned. That's nice. Okay, then maybe we can use this one to kind of add stuff until it breaks. So let's just create a struct. The struct, and it happens to have a type of the const okay, and we're going to create a destructor, the struct, and it's going to be, in order to test something, we need to have some other arguments. So we're going to have a double, I call it S, and then we're going to set like L4 is going to be 1. SL. Okay, and this might work. Let's see if it works. Ooh, magic. Okay, so we kind of have types. Do we have functions as well? And then we can return type. We write a square, takes a type, and it's going to return t times t. So now we are taking x and we are going to use this function, which is the generic and square, and we are going to use int, and then we are going to use x. So let's see if that works. No, we don't have any. So this didn't work. We are not able to do the this function. Is it crashing there already? Yeah, so it crashes here already. That's interesting. So this particular test is interesting. So if so if it's not matching, then we have this problem. So it's just a function, right? So something happens with the functions. So what we found this time is t. Okay, so the problem is t. Is it a template? Shouldn't be a template. Oh yeah. Why do I have this? It doesn't matter. It shouldn't be there. Because just because something is a template doesn't mean like if it has a module that has a template, this doesn't mean it has a template. So that's completely wrong. So let's just remove that. That check was broken, completely broken. It was true before, but not anymore. So okay, so now we get square. Let's see. That was just some broken stuff. The generic, okay, it expected 2. Yes, that's reasonable. So we're going to set that to x6 then. And then we get 16. Or maybe we should set that to the const, right? And then we have like 3 here, and it's square, x equals square, but whatever. Okay, so we had 4 from the oh sorry. Okay, x couldn't be found. What is this then? Okay, the const can't be found. Okay, so that's interesting. But the t you had stepped away to make more. It wasn't the t that was the problem, but the t. Okay, yeah, maybe. Let's pour myself some tea, by the way. Now the problem here is that when it analyzes the function bodies, it should know about these the modules, and it doesn't. So that was one of the things I forgot here. So let's see, we are in here, right? And then we're going to do the analysis of the functions in here. Here are the we're doing stuff. If it's in here, we go the context in it, right? But now we have to set when we analyze a function body, uh, at that point we should I think this is the only call on the function body, right? Okay, yeah, so in this case we're gonna get like the context itself. It's going to have like a generic instance is the if it is, if function is templated, then we are going to get the decal pointer func instance, generic instance by name, and otherwise it's a null, but we're gonna remain, so we're gonna call that instance ID instead. Okay, so I think that should fix things. Woohoo! That works. Okay, next up. So what about if we do something like this? If it only exists if the const is greater than 3. Otherwise it doesn't exist. Or is less than 4. Right? So what happens now? Okay, it's there. What happens if I increase this to 4? Oh, good. So it works for the this if. So now we get to the tricky parts. So we are getting the module which we, oh, maybe I do that tomorrow. So at least some things are working now. We could just run this with this testing for the standard library, and you would see like some of the bugs that show up. So okay, so we get like, let's see what we didn't have, working was be like, okay, real could not be found. That's interesting though. Obviously here real is maybe defined. Yeah, so you see it's defined here, but why doesn't real work? Maybe something has happened here. So okay, we could do this. So it looks like if I nested it, so we have the struct 2, and then we have like a union, and inside of that there's a struct, and then it has like type. We have struct, and it has type A, B, right? So does this work, or do we get some error from this? Oh, sorry, I have to run my own stuff, otherwise the problem will be different. All right. Okay, we got an error for that. Yeah, hooray. Okay, so let's see why. I think we are going into things and then trying to resolve the type, right? So we are in here, right? We in the context here that we are in. Do we have an infer here? Do we know what that we are in a generic? No, we don't know that we're in this generic subtype here. So what happens here? So we're going in here, right? So and then let's we are in this context, and the context has let's see here, it doesn't have a generic instance. What? So when we're up here, we are going to analyze this declaration, right? And the context should be should be templated. But we have the instance being 0. The decal itself is this one, and is templated as true. So what will happen when it goes down into this, it's basically probably it will do something funky. So okay, I'll just go in here, I think. So we went there the first time. It was the this first struct, which worked, and then we are going for this the second time. So now we have this other struct, which is a 5 double, and right now the context knows about the instance it is in, so we are fine, and we go in here and then we try to analyze the attributes, right? And what happens to them doesn't that change anything. Okay, we are fine, and we are resolving the implemented interfaces. Everything is fine so far, right? And blah blah, we're going in here, and then we are doing a Sima decal stack store. That should not change anything. And then we are, if it's a union, then we are going into analyze struct members. Okay, so we are fine, as like still quite fine, and then we're going in here, I think, and we're going to like get the struct members, and hang on, we are getting deeper into this particular struct. So now we're going to analyze the struct member itself, and just going to jump over things here, and now we are doing something with this unit. So here we go with generic sections and whatever. Okay, so then we are setting this unit to whatever the parent unit was. And then we go to change the attribute, blah blah blah, and then we analyze the attributes for this one, and we still haven't changed that particular thing, so we should be fine. We are not removing the generic instance that it is holding on to, but what happens then? So we're kind of fine as still here. So then we go into analyze the decal here, right? And I guess here then things start going like sideways, because we should be inheriting this thing. So that's the problem. If you analyze something and you are already in a generic instance, you should continue, I guess. Or should you? You shouldn't. I don't think you should. So the problem is more like when you do like this and it sets something, like you analyze a struct member here. So like decal is so if parent is templated, then we're going to do the same thing for the underlying one. So we're going to set is templated true, and decal instance ID is going to be the parent instance ID. So then we are sharing the instance ID and things should work. So Okay, so now we are through that part. And like this is this is the word, like, don't do this. Please don't do this. Don't develop like this. This is almost like wipe coding. But there are so many cases that I would have to like think, like, how does this work for that and that and that situation, that it's really really hard to do it some other way. Okay, so we got some problems. So dummy could be found. Sorry. Okay, so dummy can't be found. Where's the dummy defined? In here. So the dummy is here, a local, right? So now we get to some problems here. So we have a local, and I don't know if you remember, but I said like there's going to be a problem with looking up the locals because it's, you know, it's, they are excluded, and that's not good. So what we're going to do here is we're going to so we have this test already. We are going to have like a type bar, and it's going to the type bar is going to take a value from a const that is local. So we're going to have like a bar. It's going to be local, right? And then we're going to say, okay, type pointer Bass is going to be like this, because now we have the problem that I was talking about. So we're still not like, was still not working at all because I didn't implement that. That's methods, and methods going to be like a bit insane to do anyway. So yeah. So okay, we failed to find them, right? And that's something we kind of know about because we are inside of here, right? We are in this generic instance. Okay, we are hang on, we are doing, where are we? Here we are. We have the local, right? So we are in here, and we do the lookup, and then we do resolve with no path symbol, and then we'll go in here and try to find the local in this particular context. But we're not, when we're doing this, and that's just locals, sorry, these are just locals for they are not applicable. Then we have the local symbols, right? But our symbol might be this, if it is a if it is parameterized, then it could be also a local symbol here with another name. So we are looking at this here, and then we couldn't find it, so we're looking at it in global, and we're like still can't find it. So let's see here. So we are oh, never mind. I realize I'm getting a bit too tired for this. So we're not getting found. Well, that's interesting though, because in this unit, oh wait, we probably don't save any of those. Like when we're doing a register of all the particular things in there, we're probably not saving that the locals, the local symbols that have visibility local. I'm guessing that's the problem. Editor, I'm just using CLion here. But okay, I'm kind of, it's 20 past 2 and I should be getting some sleep, but we've gotten some progress. So what we know that the problem is right now, what doesn't work is like the problems are, so one, we have the local local symbols, and then another one that is known as like methods. We haven't tested that even. So methods. And then after we are done with this, I mean, this is just like before, right? But then we can start doing other things. And what I want to do is also have the secondary generics, but that's a feature for maybe it's not for now, but we'll do it later. Where you can kind of, oh, sorry, we could have like a generic on top of a generic. So you could get a generic function of a generic type, so that the types method could be generic. Anyway, it's a less useful thing. But those are the ones to fix. So yeah, thank you for watching, and check in next time. Goodbye.